All right, so you guys can see that. So now I need to come over here and I need to, okay, you can't see that. What am I doing, Mrs. Sherman? It helps if I present. Okay, present my screen, share. Now you can see it, okay? And I'm gonna pin it over here so you can see it. And now we're all on the same page. Here we go. What a beauty. Okay. So the first thing we need to just remind ourselves of, because I know there's been a little vacay, but it should hopefully come back to you. Miracle, we do still expect that you remember things. Make sure you know the two forms of a quadratic equation. There was a third that we talked about, intercept form, but that's not going to be on the exam. So for a text form, it's just our good old y equals a parentheses x minus h squared plus k. We've used that one quite a bit. And then standard is y equals ax squared plus bx plus c. Okay. Oh, yes.
Will we need to know intercept form?
No, it's not on there. So that's why I had on the review and we took it off because we didn't spend enough time on it to feel comfortable. So that was fine. Like we mentioned it, but not a big deal. Okay, so we can see there are two graphing on here. I just did one of each type. I can't remember. I think there's like one graph on there. And once again, I put a lot of stuff just to remind ourselves, but you might not see every single thing on every single problem, but it's just a good reminder of what we saw from before vacay. So this is a lovely equation in vertex form. So we should know the vertex. And the vertex, just be careful. It would be 4 comma negative 1. Remember, just for in here, you do the opposite sign because the minus comes from the equation. And then negative 1. The axis of symmetry, we know it comes right from the vertex. It would just be x equals and then 4. So whatever the x from the vertex is. Please make sure you write x equals. So don't just write 4. 4 means nothing. It needs to be an equation. Does it open up or down? So you can graph it and see what happens. And we're going to do that in a second. But just as a reminder, if you look at this a, this number out in front, if that's positive, it's going to open up. So if it's negative, it flips it upside down. So if I'm talking about a maximum or minimum, if it opens up, the vertex is at the bottom, that's a minimum. Okay, so I can do a lot of these without even actually graphing it, which is kind of nice. And sometimes I might just ask you a few of these things. What's the y-intercept? So I don't know just by looking at the equation. So what I do, just as a reminder for any y-intercept, if you don't just know it, you can plug in a 0 for x. Right? Because anytime anything's on the y-axis, that means the x is 0. So you could just throw that in. And just figure out, just simplify that. So 0 minus 4 is negative 4 squared is 16. Times 3 is 48. Minus 1 is 47. So I'm going to say the y-intercept is 0, 47. So I'm not necessarily going to be graphing that over here, but in case it asks for it. To find the zeros, you basically just set your equation equal to 0 and solve for x. So to find the zeros, I'm going to set my equation equal to 0 and solve. Now we said with vertex form, I don't necessarily want to do quadratic formula because it's not in standard form, which is what we need. So when I do vertex form, a lot of times I use square roots. So I'm going to add 1. So 1 is going to equal 3 times x minus 4 squared. I'm going to divide by 3. I'm kind of running out of room here, but you get the idea. I can work next to it. So I end up with 1/3 equals x minus 4 squared. And I'm going to take the square root of each side. Oh man, I really left myself without a lot of room here. So Mrs. Sherman getting that. Okay. I'll just kind of work over here. Sorry, going into my graph here. Just be careful. 1, when you take the square root, that you do put a plus minus. 2, we have a square root of a fraction. So I'm going to take the square root of the numerator, which is just 1, over the square root of the denominator, which is square root of 3. I don't want to leave it like this because I never want a radical in the denominator. So I'm going to rationalize that. And that would give me plus or minus root 3 over 3. And that's going to equal x minus 4. This one's kind of annoying just because of that radical. It just makes it annoying. And if I add 4 to each side, I'm taking up enough space here. I just end up with the answer of 4 plus or minus root 3 over 3. Okay, so that was a little annoying. I don't think they get that in detailed, but just make sure you know what to do if you see that radical there. And then I can actually answer all these without even a graph yet. The domain is all real numbers. There's no restrictions. And the range, since it opens up, that means the vertex is the minimum. Everything's above it. It would be y is greater than or equal to, and you just take the y from the actual vertex. Okay. So some of the problems, they might ask you that stuff, and you don't necessarily have to graph it to visualize. Yep.
Shouldn't the range be y is less than or equal to -1 since it's going down?
No, it's going up.
Oh, okay.
Sorry. Yeah. So it's up here. So since it's going up, everything would be above it.
Okay.
Now we actually need to graph it. So that's kind of an important part of when it says graph. So I always just do like a little, find a few points off to the side. I make sure that my vertex is in the middle of those points because the vertex is in the middle of your graph. And I basically just choose a few x's to either side. So if this is 4, I'll choose 3 and 2, and then I'll choose 5 and 6. And what I do is I just take each of these and I just plug them in for x and then simplify and see what the y is. So one thing I'm always looking for, so this is 11 and this is 2. You're looking for it to be symmetric. So this is, I actually technically only need to find one side. I like to find the other ones just to make sure I'm right because I tend to go crazy sometimes. And then when I plug these in, this came out to 2 and 11, and I see that symmetry there, which tells me I'm on the right track. So if something went wrong, that would be a good place to kind of catch it.
Ms. Sherman?
Yep.
I had a question. Last year for like all real numbers for the domain, we did like a line.
The R. Yep, you can do that. Do this.
Yeah.
Yep, you can do that. It means all real numbers. Absolutely. Yep.
So like on the test thing, can we like leave it with like the plus or minus? I mean like the radical thing?
Yes. Yep. The only time you're going to give decimals is if it's a word problem.
How do you tell the difference, like if it's a max?
Well, I'll show you on the graph in a second. Let me graph it and then you'll see. So I'm just going to do a quick sketch of these. 1, 2, 3, 4, 5, 6. I need to go up to 11. 3, 4, 5, 6, 7, 8, 9, 10, 11. And then, it doesn't have to be perfect or beautiful, just in a general idea of what's happening here. 3, 2, 4 goes down to -1. That's symmetric, so you can kind of just reflect them across. You could have your technical thing there. And then that gives me my nice parabola. So once again, if you're confused about the opening up or the max or min, that all actually comes from this number in front, that A. If that's positive, it's always going to open up and be a minimum. And when that's negative, which will happen here, it flips it upside down. So you can always refer to that first number there, and that gives you a lot of hints. So depending on the problem, it might ask you some stuff, and you don't necessarily need to graph it to visualize it. So hopefully just looking at the equation and getting an idea will help you out there. But that was number 1. And once again, like there's not going to be 10 problems like that. I think there's one problem that you're actually graphing. So we're not trying to overwhelm you with a number of problems. I don't think the test is any longer than this review. So, yep.
So if it opens up, it can't be maximum?
Yep, if it opens up, it's always going to be a minimum because the vertex will always be at the bottom. Yep. Okay, so number 2. Oh, yeah.
Is the domain usually all real numbers?
It's always all real numbers for quadratics. Yep. So for any quadratic, just write you're all real and you're good. Yeah, there's not going to be any restrictions because there's nothing fancy. Okay, any other questions before I move on? Okay. So number 2 is kind of the same idea, except we have something in standard form. So good old standard form. To find the vertex, we're going to do negative b over 2a. So that's something, if you forget it, to write down. So that would just be what? Negative, just be careful, negative 8 over 2 times negative 2. And that's going to come out to be a negative 2. So negative 2 comma, I keep squishing myself here. And then remember to find the y that corresponds to it. You basically just take that x and plug it in. So I would do negative 2 times negative 2 squared minus 8 times negative 2 plus 1. Just use your calculator. It does all the order of operations for you. And the y comes out to be 9. So negative 2, 9. So if you make sure you know how to use your calculator, you should be in good shape. So a lot of the answers kind of come from that vertex. So if I say, what's the axis of symmetry? It's x equals, and whatever the x from the vertex is. Does it open up or down? So this comes from, once again, A, see how A here and A here? Oh, you can't see them because I'm not looking. A here and A here, they're the same A. I know they're different forms, but you always look at A to tell you whether something opens up or down. If it's negative, it opens down. That means it just takes the U and it flips it upside down. And if something opens down, then that means it's a maximum. It's going to be at the top of the U. For the y-intercept, the last one we plugged in a 0 for x. For this one, I mean, you could do the same thing. But this C is always the y-intercept. So it actually saves you a step. The y-intercept would be 0, 1. So it's kind of easy in standard form. It's just right there for you. The zeros, we're going to plug in and set it equal to 0. And then once I do this, you can see if it's factorable, this isn't. So I just go back to a quadratic formula. If it's in standard form, I know it's going to work. So it would be 8 plus or minus the square root. I grab my calculator, and I'm just going to do my discriminants there. So, right, your calculator is your friend. Use it. 4 times A times C. It comes out to 72 as the discriminant. All over 2 times A, so that's over negative 4. I am going to simplify that radical. 72 is divisible by 36, which is 6 root 2. 4. And then I can reduce this. And just as a reminder, whenever you're giving an answer like this, you don't want a negative in the denominator. So we're just going to kind of divide by negative 2, if you want to think of it that way. So that would give me negative 4 plus or minus. That would be 3 root 2. Because if I divide that by negative, the plus minus just flips to plus minus, which is kind of weird. And then the bottom, that would be over 2. But you don't want negatives in denominators. It's all sorts of ugly. Domain, all real numbers. You can put that little symbol. It kind of just looks like an R with a double base. And then the range is Y. Since it's opening down and we have a maximum, everything is below the maximum, so it would be less than or equal to, and that's the Y from your vertex. So without actually graphing anything, we can answer a lot of questions, but now we actually want the graph. So I'm just going to find a few points. My vertex is in the center, and I'm just going to do a few X's around that. Okay, so I just kind of fill those in. And then I just plug each individual X into the original equation to find what the corresponding Y is. Once again, I'm looking for symmetry here. I'm sorry, I already did these. So that's 1 and 7, and then that's 7, 1. And that's a good way to check that you've picked the correct points. And then you can just do a quick sketch of those. Doesn't have to be anything too fancy. What do I need to go up to? 9. 1, 2, 3, 4, 5, 6, 7, 8, and a 9. Negative 3, 7, right there. Negative 2, 9. And then we just do our little reflection. We do have our axis of symmetry. That's a terrible line, but you get the idea. And that's a little crooked, but go from there. So just as a reminder, both of these have two x-intercepts, right? So this has two x-intercepts, and we can see that with a plus minus. This has two x-intercepts. You can see that with a plus minus. You can have one x-intercept. So this isn't on here, but I'm just reminding you. You could have something like that with one x-intercept. It just means the vertex is the x-intercept. So if that ever happens, that's that. And you can have something with no x-intercepts. Hey, can someone remind me? Without actually graphing, how can I tell if something has no x-intercepts? It has to do with the discriminant.
It equals 0.
Not if it equals 0, if it's
Less.
less than 0. Okay, if the discriminant is less than 0, that means there's no x-intercepts. Does everyone got that?
Oh. I'm having past something what you say.
I mean, could I be any more obvious that like there's a question like that on the exam?
I kept forgetting we have a test tomorrow. That's why
Oh,
I'm
okay.
actually coughing.
Because that was like a little hinty hint. Okay. If the discriminant is less than 0, that means you have no x-intercepts. Okay. Now we get to our favorite type of problem, boys. A 3x3 system. Actually, I did this one before, and it's pretty painless. I mean, I know it takes a little bit of time. I believe the one on the exam isn't like, it's not like weird fractions or anything. It should be like pretty nice numbers. So let's just go through what the heck do we do when we see 3 points, and how do we write a parabola from there? I always hate the setup of this. And we'll go from there. So once again, I'm going to start thinking about standard form. Y equals ax squared plus bx plus c. Okay. And basically what I'm going to do is for each point, I'm going to plug in x and y. That's going to give me a new equation. And then with those equations, I'll do some either substitution or elimination, whatever works for you, works for me, and go from there. So if I start with the first point, it would be 15. I'm kind of moving off to the side, so I just have room. 15 equals, and then it would be a times 1 squared plus b times 1 plus c. And if I rewrote that, that would be 15 equals, I'm just going to write it, 1 squared is just 1, and 1a I can just write as a, and then plus b plus c. Okay, so that's my first equation. Not bad. Second equation, I do the same thing, just with different numbers. 31 equals a times 3 squared plus b times 3 plus c. And I can simplify that to be 3 squared is 9, so that would be 9a plus 3b plus c. Okay, feeling pretty good. We got equation 2. And then the last but not least, we got 6 equals a times negative 2 squared plus b times negative 2 plus c, which would simplify to 6 equals negative 2 squared is just 4a, but then that would be minus 2b plus c. Okay, so we have these lovely 3 equations, so make sure you know where they come from. Just plugging x and y into that standard form. So what I did as I was doing this before is I said, well, I noticed they all have c's, like there's no coefficient to c. So I decided I'm just going to take one of the equations and I'll make it negative c. So I'll just multiply one of them by -1, and then I can just do elimination. If you want to do it a different method, you like substitution, go for it. But what I did is I multiply by -1. I just picked the first one. I'm going to rewrite it as -15 equals negative a minus b minus c. And now I'm going to use elimination. Okay, so let's see what I get. So I'm going to take this one where I just multiplied it by a negative. I'll take that. And I'm going to match it up with another equation. I'll just pick the second one. And I'll do my thing here. So when I combine these, I get 16 equals 8a plus 2b. That cancels. Okay. So I'm going to kind of I like to circle things as I go just so I don't lose stuff, because there's a lot of work that is involved in these, right? So basically I'm just going to do the same thing, except I'm going to do it that one that I changed to the negatives, but I'm going to do it with the third equation now. So So I'm just going to do it right underneath just so I still give myself some room. All right, and when I do that, I would get -9 equals 3a minus 3b. The c's cancel. Okay, so I got two new equations that have two variables. Okay, feeling good about life. And now I'm going to line those up. Okay, so it's just kind of like working through. And saying, what do I do from here? Well, from here, I need to eliminate something. I chose the b's. I said, because there's nothing really, I can just multiply 1. If I have a 2 and a 3, I'm going to make them both a 6. So I'll multiply this by 3 and this by 2. They already have opposite signs, so we're good there. And I end up with 48 equals 24a plus 6b. And -18 equals 6a. Excuse me, that should be minus 6b. And after all of that, I get 30 equals 30a. I'm going to take a break after this, and a equals 1. Okay, so I'm going to stop there for a second. I know it's a lot of stuff going on. Once again, we're not giving you a lot of these. There's one. You're going to do your best. You're going to show your work. You get partial credit. So you're just, if you hate these and you're like, these take too much time, then leave it as the last thing. Yep.
Is there any like decimals or fractions?
I believe they come out to nice numbers.
How many questions are on the test?
I can tell you. I think it's like 9. It's like pretty much the same as this review, but I think there's not 2 graphs. I don't think there's only 1 graph.
Are we gonna get a bonus?
I think there is a bonus, yeah. All right, so that's the hard part. It's just finding that first one. Then you kind of just backtrack and just keep plugging it back in until you find the second and the third. So if a is 1, I take a and I plug it into one of these that have 2 variables. So I picked this one, I think. So I took -9 equals 3a minus 3b, and I plugged a in. And then I could just do a little simplifying and solving. I'm running out of room. This thing is not my friend right now. What's that give me? -12 equals -3b, b equals 4. Oh, okay. It always feels like you feel like good about yourself when you get like a nice answer. Okay, b equals 4, feeling pretty good. And then last but not least, once you have a and b, you go back to one of the original equations with the 3 variables and you plug into those. So I just picked that first original one, 15 equals a plus b plus c. Once again, I'm kind of running low on room here. So I'm just going to do it right here. So 15 equals 1 plus 4 plus c, which would give me 5, which I would subtract. So c is going to be 10. Okay, so now I'm feeling real good because I have A, B, C. They all look nice. Please just make sure you answer the question. The question isn't what's A, B, C. The question is write the equation of the parabola in standard form. So you plug A, B, and C into standard form. And your final answer, I'll write it up here, is y equals 1x squared plus 4x plus 10. Aggressively circle, and then we know that's the answer. Okay. So just make sure you throw those back in. So once again, if you're a person, you get caught up on these, you're like, oh my God, like I always make, just, you can, like, there's no right or wrong way to do a test. You can go out of order. If this is going to stress you out, do everything else first and then save this for last. Because if nothing else, you can do some of it. You can get partial credit. If you get messed up, then it's one question. It's not like, oh, I messed up and now I skipped 6 questions after that because I like spent 25 minutes on it. So especially if you're not the best at time management, do your strengths first, leave the ones you're weakest at for last. But please don't like just go in order because that's the order it's in. It's kind of random. Okay. So on the back, we have a few things you're going to see as well. Converting between forms. So if you want to convert to vertex form, the main thing is to find the vertex. So I'm going to do -b over 2a. So that's always the main thing with the vertex, that step, which would give me -4 over 2 times -1. which comes out to just be 2. And then once I find that, I go back and just plug that in, right? So I just always go back. Just be careful with your calculator. It's negative, and then you would do parentheses 2 squared plus 4 parentheses 2 minus 11. Sometimes that negative, if you put it in the parentheses, that's not correct. So that means you're plugging in a negative. So just be careful. When you plug that in, it should come out to -7. That's all you need. So I kind of like these ones. Remember, your A for vertex form and standard form are the same A. So if the A here is -1, then the A in vertex form is -1. So you don't have to do any work for it, which is nice. So you're going to plug it in. You're going to get -1 and then parentheses x minus 2 squared minus 7. Okay, so remember, A is the same no matter what form you are in. And then for 5, for standard form, you're really just like simplifying out and kind of distributing and doing all that fun stuff. The main thing to remember is when you see x minus 2 squared, you have to rewrite that as x minus 2, x minus 2. That's the big thing. We call that expanding the binomial. Once you've expanded it, you're going to distribute it. So I usually distribute the parentheses first, and then once I have the answer to that, I multiply by 4. You can kind of do it in whatever order you please, but I always find I tend to not make as many mistakes that way. So when I distribute that, I'll get x squared. What would that be? Minus 4x plus 4. But remember, we have that 4 out in front. And then when I distribute through, I'll get 4x squared minus 16x plus 16 plus 5. And then I'll combine like terms in the end. Boop, boop, boop. Excuse me. And then number 6, these ones are just kind of a lot of like plugging in, finding little things. So write an equation in vertex form if you have the vertex and a point. So just as a reminder, vertex is h and k. Looks terrible, but you get the idea. A point is x and y. So what we do is just take vertex form. We're going to plug in what we know, which is h and k, x and y. So that would be -31 equals a, and then x is 5 minus h is 2, and then squared plus 5. Okay. So we just plug in what we know, and the main goal of this is to solve for a. So it's just a lot of simplifying. 5 minus 2 is 3. 3 squared is 9. And if I subtract that, that's what, -36. So a is -4. That's it. That's all you have to find. Excuse me. You do have to rewrite it. So just write when you're writing an equation, you plug in a, h, and k. There we go. I kind of like that grouping. I feel like this is like the first few questions on the test. Easy, nothing too crazy. A lot of just kind of knowing how to go between forms, how to simplify things, and go from there. So the last few are some word problems, all ones that we talked about, but once again, we probably need to jog our memory here. So number 7, we had worked on right before vacation. It's when we're talking about, we want to increase prices, but we don't want to increase it too much because then people will stop coming because blah, blah, blah. So let's remind yourself of how to do this. There is one like this on the exam. So if this is something you're like, oh, I kind of remember, that might be something to, maybe make a little note of, and go from there. So a store sells 3,000 wigs at $20 each every month. For each $1 increase in price, they would sell 100 less wigs. Okay, so what's the price that would maximize the store's revenue? So they're saying, okay, well, even if I lose a few people, if I increase the price, I'll still make more money up to a certain point. When you're losing too many people, then it's just a big disaster. So when you're doing a problem like this, I'm a labeler. So if I label, I tend to stay a little bit more organized. So just remind yourself what X represents. X represents the number of $1 price increases. So how many times should they increase that price for it to make sense for them? So whether you're talking, we talked about some of these before vacation. I think we were talking about bus fare, number of whatever, how many increases for that or whatever else. And we'll go from there. So we're really talking about two things. We're talking about the price per wig. Well, it tells me the price per wig is $20, right? But if I do that price increase, I'm adding $1 every time I increase it. So we're starting with the 20, that was the base price, plus $1 every time I have an increase. And then we're talking about how many wigs I'm selling. So he's selling 3,000 wigs a month, but for every price increase he has, he loses 100 wigs. I don't know. Loses selling 100 wigs. I don't. My brain is not working. So the main goal is to always come up with these kind of two expressions. And what we're always going to do with them is we're going to multiply them together. So to get the income, we're going to multiply the price times how many I sell. So I'm going to have to do a little bit of distributing. The nice thing is you don't have to do like anything crazy with quadratic formula. Once we do this, it's just finding the vertex. So it's really just getting it in that standard form. So then you can just do that quick negative b over 2a. So if I distribute this out, I would get 60,000. So once again, these numbers are a little big, but that's okay. And then that would be what? Minus 2,000 plus 3,000. So that would be plus 1,000x. Once I combine those like terms in the middle, minus 100x squared. But what I always do is I do put that in standard form. So I'm just going to rewrite it. Okay. So and this one, the setup is kind of the hard part. It's just like getting to an equation. That's all I want is an equation. And once I have that equation, I'm going to do negative b over 2a because I want to find the vertex, right? We talked about when you see the word maximize or minimize, that's all vertex. So negative b over 2a would be negative 1,000 over 2 times negative 100. And that turns out to be 5. So I'm just going to write x equals 5. So this is why I like labeling, because I feel like at the end they're like, what is that? Is that the price? Is that the number of wigs? Is that the people? Is that the whatever? But if I go back and remind myself, that's the number of $1 price increases. So he can have 5 price increases of $1. Okay. So what is the price that would maximize the store's revenue? Well, if he had 5 $1 increases, he could increase it $5. So that would be $25. $25 per wig to maximize revenue. Okay. So in that one, once you get the equation, it's kind of easy. It's just so I can find the vertex, no problem. Or find the first part of a vertex and then plug it back in. But just make sure, one, that you know what x represents. I feel like that's the big thing here. Like, what the heck am I even looking for? You can set up your expressions, which aren't bad once you read through it, and then multiply them together. There is one like that on there, so just as a heads up. We have 10 minutes? Okay. Whew. Sorry, I'm like I just want to make sure I get to everything. I don't want to leave you on the lurch here. So for the 8 and 9, they're not too bad. So we this one you do have to read through. It's not necessarily hard. You just have to read it. It tells me the velocity is 48 feet per second, so that's v, and it tells me it's 4 feet when it's released. We call that h, not t. You don't. It's just kind of labeling it. So if it says rewrite the equation, you can just write it as h if you want. I don't really care. It's negative 16t squared plus the velocity is 48. So you just have to kind of throw them in the equation. And then h naught means just the original height, which is 4.
Is this how it will be on the test?
I will just say if it's on the review, there's a good chance it's going to be on the test. Okay, from here, this is all stuff we've done a million times. What's the height of the ball after 2 seconds? Okay, just plug in 2 for t. We can do that. So I'm just going to kind of do the setup for you guys. What's the maximum height of the ball? The second you see the word maximum or minimum, depending on the problem, you are going to think in your head, what is the vertex? So you're going to do negative b over 2a. Just remind yourself when you do that, that gives you the x, or in this case, the t. So then you'd have to plug t back in to find the height. I'm just going to kind of give you hints on these, and I'll give you the answers to them in a second. And when will the ball hit the ground? You just set your h equal to 0. In this case, I would just do quadratic formula. And when you're doing quadratic formula or you're solving for anything like time, I would, or it's going to say, make sure you put it in a decimal. So I don't want radicals. So I'm just going to kind of give you the answers to these. You can do them out if you want, or you can just check them later. In this case, the height ends up being 36 feet. So that one you just throw into your calculator. In this case, you're going to do negative b over 2a. You're going to throw in what you know. Just be careful. It comes out to 1.5. That's not your answer. That's the time is 1.5. So then you have to plug t back in. So basically it's finding the whole vertex. And the height comes out to be 40 feet. And then last but not least is just throwing that into the quadratic formula. 2560 over negative 32 equals negative 48. So then what I do from here, like once again, don't break down that radical, just throw it in your calculator and figure out what the decimal is. I got like 50.6. Sounds good to me. And then I split it up. And I get 2 answers. The negative one I don't care about. I only care about the positive.
So you'd want to put that in decimal form?
Yes, for word problems, we want decimals because it just makes more sense. Like if you told me something was negative 48 plus or minus root 2560 over negative 32 seconds, I would be like, I don't know what that is. So yeah, word problems, even though decimals. And last but not least, the next one's kind of similar. And once again, I'm recording this, so you can always, if you're bored, you can watch back, or you can go back to a section if you didn't get it. I will put this answer key, and I'm sorry, I meant to put the answer key to the other thing up, and life, So I read through, we're talking about the profit of selling ballet tickets, and it gives us a nice equation. X is the price of the ticket, P is the profit. We want to find the ticket price that gives the maximum profit. That's always the word that I'm looking for. And also find the maximum profit, okay? And then find the price range. I'll show you how to do that. That's quick. Maximum, vertex. Or if it says minimum, depending on how the thing is. So we just throw that bad boy in. Sorry, I know I'm doing this kind of quick, but I just wanted to leave a few minutes for questions and for a little break. So $20 per ticket is like the good spot. That's where we're going to maximize our profit. But it also asks, what is the maximum profit? So you just throw 20 back into the equation. Okay, I can do that. I can't see as I'm writing. And the profit would be $59.40. So that's the maximum amount they're going to make. Basically, all I did was found the vertex, right? That's what the answer to that is. So then it says, what is the price range for tickets where it will make a profit? Well, if it makes a profit, anything over zero, right? So basically, it's just asking you to find the zeros, and then in between those two zeros will be your answer. So anytime it asks for that, you just set your equation equal to zero. Solve it. I'm going to do quadratic formula. Once again, I am going to get a decimal, because just for word problems, for context, it makes a little bit more sense. So I'm just going to kind of do my workout. I know I have mine already written out, so I'm probably doing it way faster than you. So I'm sorry, because I'm just going a little quick here. I'm going to get two answers, and that's going to be my range. So I'm rounding it to the nearest penny. Yeah, 2 decimal places. So if it was I think it came out to like 0.1009 something dooba. So you can't say 0.10 because 10 cents wouldn't be enough. So I'm going to say from 11 cents to 39.89. It's around that. And if you do that out, you can find it. Would be the price range where we would make a profit. 11 cents. What do you know? There you go. So I'll leave that one there for a second. Sorry.
So P is
Profit.
like the total profit?
Mhm.
Okay.
Yeah. So you make a profit if you make anything over $0, right? Even if you make $1, that's profit. It's not just where you started. Okay. So sorry, I went through the work of some of those a little quick, but it's all work. I mean, you guys know how to do quadratic formula. You know how to find a vertex. So it's work you kind of know how to do, or you could do on your own. So I will be posting this answer key. I will do it before I leave, so I don't forget, because I'm the queen of that. I spent like forever on that other one. I can't believe I didn't post it. I just had it sitting here. And that's that. Sorry, I wanted to leave a few minutes at the end. So right now, excuse me, are there any specific questions? Reminding yourself. Weird noises. If it's on here, you're probably pretty much gonna see it tomorrow, and they're pretty much gonna be similar to these. So this is something I would look over. You can have 1/2 sheet of paper, one side, and you are passing it in at the end. So please don't like crumple it up. I want it. So hopefully there's no cheating. And then cohort B, I'll talk to you about. You guys are taking it later in the week. Tomorrow you're going to have an activity that you're doing. I'm going to, or something that you're doing. I need to find what it was. We talked about it before vacation, and I have no recollection. I'm going to be honest with you. So for cohort B, I will be posting something, but still sign on to the meet tomorrow, and I'll give you directions from there. And I think that's it. So people here, I know we kind of cut it close. So feel free to take your mask off, move around, have a little masky breaky. People at home, if you have any questions, you're more than welcome to answer them. I am going to take this off.